This video will be about factoring. So when we start with factoring, the first thing we need to be able to identify is called the greatest common factor. We often just use the letters GCF to stand for greatest common factor. So if I'm looking at 2x squared and 8x, if we want to know what the greatest common factor is, we want to know the biggest number and letter that would divide into both of those. To do that, the easiest way is to break them down. So 2, I can't break down any further. The only things that multiply to be 2 are 2 times 1. And if we ever come up with a 1, we don't want that. That's not helpful to us. So we just use 2. But then x squared literally means multiply x by itself, so we really have 2 times x times x. 8x we can break down. 8 is 2 times 4. 2 again, if we did it, would be 2 times 1, but we don't want a 1, so we get, oh, I went too far. So we don't use the 2 times 1. 4 is 2 times 2. So we only use the ends of the branches. We're not going to use the 4 because it got broken down further. So that means we have 2 times 2 times 2, and then we also bring down the x. So now between our broken down parts, we want to see what do they have in common. This first one has a 2. The second one also has a 2. The first one has an x. The second one also has an x. The first one has another x, but the second one does not have a second x, so that black x was not actually in common. So now the greatest common factor would be those pieces they had in common, 2 and the letter x. So that's our greatest common factor, is 2x. Now when we have an expression where we have a plus or a minus sign, we can use the greatest common factor to factor the entire thing. Let's say we have 6x squared minus 9. So again, we're going to break down each piece like we did before. 6 would be 2 times 3. X would be x times x. 2 and 3 both don't break down any further. Both of them would use just a 2 times 1 or a 3 times 1. 9 is 3 times 3. Again, we look for what's in common. The first set of stuff has a 3, and so does the second. But that's the only thing they have in common. So now, when we factor, that common piece goes to the outside of a set of parentheses. Then anything left over goes inside the parentheses. Now we can't forget these were separated by a minus sign, so we have to put minus. And then we use the 3 that was left over. And then simplifying, we can multiply this stuff back together. So we have 3 times 2x squared, because x times x is x squared, minus 3. This will still work even if you have 3 terms. So we break it down again. 10 is 2 times 5. X to the third is x times x times x. I did actually want to include an x on the 25 as well. 5x squared, so next was the plus sign. We have 5x squared is x times x. 25 breaks down to be 5 times 5. That's the only numbers that work, so we have minus 5 times x. Now we look for what all 3 things have in common. They all have a 5, and they all have an x. So in front of our parentheses, we would put 5x. Those have been used, so we don't need to worry about them anymore. And then anything left over we put inside the parentheses. 2 times x would be 2x squared. Just an x was left on the second. Minus, and just a 5 was left on the third term. So there's our greatest common factor. Now that we know how to do greatest common factor, we can do quadratic factor. Quadratic factoring is the backwards of FOIL. So I'm going to review a FOIL problem just so we can talk about how to do the factoring. So if I have x plus 3 times x plus 5, we multiply first times first. X times x is x squared. Outer times outer, so x times 5 is 5x. Inner times inner, 3 times x is 3x. And last times last, 3 times 5 is 15. So now I add any like terms. 5x and 3x can add together to be 8x. So when we're factoring, we're going to start here and end up with the parentheses. We're going to start with the x squared plus 8x plus 15 and somehow figure out, well, this will become x plus 3 times x plus 5. Sorry about that. So we have to kind of look for a pattern. 15, we've got to figure out, well, how am I going to get back to the original numbers? And same thing with 8. How am I going to get that back to the original numbers? So 15, to make it into a 3 and a 5, that would be multiplication. We have to do 3 times 5 is 15. 8, using the original numbers, would be plus 3 plus 5 is 8. And that's the same pattern every time. It's always got to multiply to be the last number and add to be the middle. For example, x squared plus 12x plus 20. So we're looking for numbers that would multiply to be 20 and add to be 12. We also know that this is backwards FOIL, so it's going to end up having 2 parentheses. And when it's just an x squared out front, I know automatically that these first 2 parentheses are going to be x. The first spot in each parentheses will be an x. So the assignment itself showed it a little bit different, but I think this is easier, so I'm going to show you this way. So now we just have to decide what are some numbers that multiply to be 20 and also add to be 12. So things that multiply to be 20. The one I think of right off the bat is 4 times 5. We know 4 times 5 is 20, but now we've got to also check that 4 plus 5 is 12. But when I do 4 plus 5, I get 9. I don't get 12, so I can't use 4 and 5. Those are gone from the list. I know 1 times 20 is 20. So then I go check again. 1 plus 20, that's 21, not 12. That didn't work. So we check a third option. 20 is also 10 times 2. 10 plus 2 is 12. And there we go. Those are the numbers we use. A positive 10 and a positive 2. So that would be our final answer for this problem. X plus 10 times x plus 2. You may switch the parentheses. You may write x plus 2 times x plus 10. Same answer. So let's try one more problem with negatives. So again, we're going to follow that same pattern. Things that multiply to be 16, but add to be negative 8. 16, one I think right off the bat again is 4 times 4. So we go check the addition. 4 plus 4, that equals positive 8. So we're pretty close, but we're not quite there. So if I change something small about this, it'll take me to the negative 8. If I make both of these negative, a negative times a negative still gives me that positive 16, but a negative 4 plus a negative 4 gives me the negative 8. So these are the numbers that would go in the parentheses, x minus 4 times x minus 4. I'm going to do one more example with negatives. So again, multiply to be the last one, add to be the middle one. Negative 24. Things that multiply to be negative 24. I think 3 times 8 usually, or 4 times 6. But we want this to come out negative. If I multiply right now, I get positive 24. So we've got to do something different. To make a negative number, one of these has to be negative. Negative 3 times 8 is negative 24. Negative 4 times 6 is negative 24. So we check. Negative 3 plus 8 gives me positive 5. Again, that's pretty darn close, except it's positive instead of negative. If I check negative 4 plus 6, that's not even close. That's 2. So this one's definitely out of the running. The top one, though, is close. Again, I just have to make a small change. I just have to change which one is negative. 3 times negative 8 still gives me negative 24, but 3 plus negative 8 gives me the negative 5. And then again, once we know these numbers, we can put them in the parentheses. X plus 3 times x minus 8. So that ends our discussion on factoring.